increasing the size of a soap bubble from radius 3 centimeter to 5 centimeter is nearly in millijoules. Work done is a question. R1 is 3 centimeter, R2 is 5 centimeter, surface tension is 0.03 Newton per meter, given and asking you soap bubble. When we go to the soap bubble, work done is 8 pi T into R2 square minus R1 square relation. Pi answer, if you observe the answers, pi kept as it is. Surface tension is 0.03. 5 square minus 3 square into 10 power minus 4, converting into meter squares. This become 0.24 into pi. A square minus b square we split into as a plus b into a minus b to simplify. 5 plus 3 into 5 minus 3. 8 into 2, 16. 16 4s are 64. 16 4s are. Again 16 2s are 32 plus 4, 38, around 0.4. 0.40 pi. Option available is third. Say level 3. Question. Work done in increasing the size of the soap bubble from radius R1 to radius R2. 2 mercury drops, each of radius R, merge to form a bigger drop. Surface energy of the bigger drop is, if T is the surface tension, the given standard relation, number of liquid drops are 2. They merge to form a bigger drop. The surface energy of the bigger drop. Surface energy of bigger drop equal to 4 pi T into R square. Directly if you think. But number of drops are 2. I given one relation R is equal to n to the power of 1 by 3 into small r. If you substitute here 4 pi T into n to the power of 1 by 3 r whole square, pi T r square can keep as it is. Pi T r square. N is 2. 2 to the power of 2 by 3 into 4. If you search the answer here available, 2 square. 2 square, 3, 2 just 6 plus 2, 8. 2 to the power of 8 by 3 pi T r square is the answer. The solution available is option number 4. Again, the problem seems to be simple, but they have to know the 2 different relations. One is about 4 pi T r square, surface energy for forming a soap bubble, and radius of bigger to smaller drops, and mathematical simplifications brought to this answer. A vessel whose bottom has a round hole with a diameter of 1 millimeter is filled with water. Diameter is 1 millimeter. If you want, radius is half millimeter. Assuming that surface tension acts only at the hole, then the maximum height to which the water can be filled in the vessel without leakage is, surface tension of water is 7.5 into 10 power Newton per meter. Here surface tension rises to certain height, h. We discussed that weight of the liquid column equal to force due to surface tension is the principle we have to adopt to find the answer. Ft equal to mg. Force due to surface tension normally acts if you take that circumference is 2 pi r into t. Circumference of the tube is 2 pi r. Total length into time gives you the force of surface tension. Mass pi r square into h, volume of the water raised h, pi r square is base area, volume into density of water into g. The question is on height, h is required. Pi cancels, 1 r cancels. H is equal to 2 into 7.5 into 10 power minus 2 divided by 1000 into 10 power 4. H is equal to half millimeter radius. One radius term comes to the denominator into half into 10 power minus 3 meter. This cancels with this. 2 go to the numerator. 4 5s are 20. 30. 7.5 30 into 10 power minus 3 meter or 3 centimeter is the height to which it rises. Option number 3. Conceptual thought is here. To arrive to this equation, skill is required, therefore we put under level 3 questions. Yes. So in fluid dynamics, let us see the question number 1. Water in a streamline flow along a horizontal pipe with non-uniform cross section. At a point in the pipe where the area of cross section is 10 centimeter square, velocity of water is 1 meter per second. And the pressure is 2000 Pascal. The pressure at another point where the cross-section area is 5 centimeters square is. We may put level 3, but I prefer it level 4. The reason I tell you again, it is a streamline horizontal flow. We have, depending on the Bernoulli's theorem, height same, therefore half V1 square plus V1 by rho is equal to half V2 square plus V2 by rho. It is the density of water. They are asking about the pressure. One pressure given 2000, another pressure is asking means you need P2 minus P1 by rho is equal P2 minus P1 half into V1 square minus V2 square. V1 square minus V2 square. P2 minus 2000 is equal to half into, it is I write 1000 because of density of water. 10 centimeters square area given 1 meter per second. You note the velocity. I have to go to understand V1 V2. A1 V1 equal to A2 V2. Therefore V2 is equal to A1 10 centimeters square is 1 meter. The pressure at another where the cross section area is 5 centimeters square. A1 is 10, A2 is 5, V1 is 1 equal to 2 meter per second. Here centimeter, not necessary to change. The ratio cancels. So we have to substitute here. V1 is 1 centimeter square minus 2 square. So P2 minus 2000 is equal to 500 into 2 plus 1 is 3 into minus 1. A minus B into A plus B. So this becomes 1500 minus. This implies P2 is equal to 2000 minus 1500 equal to 500 Pascal. Got the answer. Option number 4. So one first thinking is the level, height of the liquid is same. So therefore we neutralized, we simplified the formula, giving up the potential head. Only taken the velocity and the pressure energy. Sum total of these two per unit mass is a constant, is a Bernoulli's theorem. For first point and the second point are different sections. It's one level thinking. When come to the second level thinking, they want to know the velocity equation, density of water, pressure difference. Third level thinking required because they are not given velocity, they are given area and calculate velocity. All these has to substitute and find the final answer. Small errors did, minus term become plus, a small error it become 2000 plus 1500, 3500. Therefore, it should be under level 4. Even small mathematical error can lead to different answer. So that the answer here is 500 Pascal. The cylindrical tube of a spray pump has cross section of 8 cm square, one end of which has 45 holes, each of area 10 power minus 8 meter square. If the liquid flows inside the tube with a speed of 0.15 meter per minute, the speed with which the liquid is ejected through the hole is. Again, it is a typical question, either 3 or 4 level. Why? Because the pipe one side has a single hole, other side has 40 holes of small areas. Number of holes are 40. Area of each is 10 power minus 8 meters square. Area of the first one is A2. If you take here, it is given as 8 centimeters square. That is 8 into 10 power minus 4 meters square. They are asking if the liquid flows inside the tube with a speed of 0.15. Again here, V2 given 0.15 meter per minute. This implies 0.15 by 60 meter per second. The speed with which the liquid ejected through the holes here required V1 how much? First here necessity is to conversion of unit. They given here in centimeter square converted to meter square. Here per minute converted to per second. Therefore level it goes to 4. Unit conversion is also included. And again here 40 holes each area. Estimate what is A1. 40 into 10 power minus 8 meters square. Now you are able to get the answer. Using the law of continuity. Answer this available, that A1 V1 equal to A2 V2. Volume of liquid flowing across any section remains constant. Now V1 is required. A2 is given as 8 into 10 power minus 4. V2 is 0.15 divided by 60. And A1 is 40 into 10 power minus 8. 8 5 times 5.03 times 10 power minus 8 if you take on to the numerator 10 power plus 4 plus 2 is 300 plus 4 is 300. 300 by 60 is 5. Option number 2. 5 meter per second. Option number 2. So here one side single hole, other side there are number of holes. Area of each is given. Consider it as a single hole of area of this much. Convert the units properly. Use the law of continuity. A1 V1 is A2 V2. Correctly substitute and get the answer V1 equal to that much. A tube tapers from 20 centimeter diameter to 2 centimeter diameter. If the velocity at the first cross section is 50 centimeter per second, velocity at the second cross section is the given diameter D1 is equal to 20 centimeter, D2 is equal to 2 centimeter. If velocity of the first cross section is 50 centimeter per second, at the second cross section is how much? It's a level 2 question. According to law of continuity, area into V is constant. Area can be written as pi d square by 4 into V is constant. This suggests V proportional to 1 by d square. Therefore, I can write V2 by V1 is equal to d1 by d2 whole square. V2 is equal to 50 into d1 is 20 by 2 whole square. 10 square 100, 5000 centimeter per second. Option number 1 is a level 2 question because only one substitution. V inversely with the d square and answer is more simple calculation. No problem in calculation also. A large open tank has 2 holes in it. One is a square hole of side A at a depth x from the top, and the other is circular hole of radius r at a depth 4x from the top. When the tank is completely filled with water, the quantity of water flowing out per second from the both holes are the same, then r equal to. It is again level 4. Very carefully have to think with words. From the top of the liquid surface, there is a square hole of side A, so that area is A square. A large open tank has 2 holes in the wall. One is a square hole of side A at a depth x. Depth is x. From the top of, and the other is a circular hole of radius r at a depth 4x. 4x from the top. When the tank is completely filled with water, the quantity of water flowing out per second from both holes are same, then r is equal to. So if it has a radius r, area A2 is pi r square. V1, and if it is V2, what they given is V1 equal to V2. Volume of liquid flowing out per second is same. You know area into root 2gh gives you the volume. H1 A1 equal to A2 into root of 2gh2. So here the given condition A1 into 2gh1, A2 into root 2gh2. But area is again they are different. When we substitute the values 2g cancels, leave it. A1 can be written as A square into root x is equal to pi r square into root 4x h1. You required r, x's cancels, r is equal to a upon pi 2 root pi, because 4 or 2 square root, if you put 2 square root 2 so here 1 root 2 pi, option number 1. So here they are different depth, shapes are different, volume of liquid flowing out is the concept, area into 2gh is a relation, A1 H1 A2 H2. Area is written in terms of square area, circular area, depth x, depth 4x. Substitution lead to this answer, r equal to a upon. A hole is made at the bottom of the tank filled with water. If the total pressure at the bottom of the tank is 3 atmospheric pressure, then the velocity of efflux in meter per second is. There is a tank, is a level 3 question. So at a depth, at what depth it is? Pressure total is here 3 atmosphere. What is the velocity of efflux? If this is h, velocity of efflux is 2gh. H, if you calculated, your answer is over. How to get H? Total pressure is nothing but pressure due to atmosphere plus rho GH. It is 1, it is 3. Therefore, rho GH is equal to 3 minus 1 is 2. Or GH is 2 divided by 1000 because density of water is 1000. Substitute in this, V is equal to root of 2 into GH is 2 divided by 1000. Alright, it is 2 atmosphere, convert into 10 power 5. It is 2 atmosphere, 2 into 10 power 5 into 2 by 1000 cancels, remains 4. 280 m can be written as 2 into 10 power 5. Answer is root 400. Option number 4, level 3. Here total atmospheric pressure given. Subtract the atmospheric pressure rho GH. Rho GH is equal to 2 into 10 power 5 atmospheric pressure converted to the SI unit and by 1000 substitution gives you that answer.